Hello everyone, welcome back again. I hope you guys are doing absolutely fine. Let us start with our lecture, that is Enzyme Technology Part 2. Yesterday, what we have discussed the enzyme technology, basic introduction. We have seen the different examples of the enzymes. We have studied the immobilization technique, a general introduction. Now we will see these methods one by one. So let us start with the first method, that is absorption. What is absorption? A physical binding of enzyme on the surface of an inert support is considered as an adsorption. The support material may be inorganic or support material may be organic. If you see the example of inorganic, it can be used alumina, silica gel, calcium phosphate gel, or glass you can use for this purpose. If you are going to use the organic substances, the starch, the CLC, the D-cellulose or D-sapedics are the perfect examples of the adsorption. Now, the adsorption of the enzyme molecule involves forces such as van der Waals forces and the hydrogen bond, which can stick or which can adsorb on that inert surface or inert support. Thus, the absorbed enzyme can be easily removed by the minor changes in pH, ionic strength, or the temperature when they are required or when we want to use them. So this is how enzyme are adsorbed on the support or the inert support. This inert support may be inorganic or this inert support may be a organic one. Now the next one is the entrapment. What is meant by entrapment? Entrapment is nothing but the immobilization of the enzyme by the physical entrapment inside a polymer matrix or polymer gel. So this is how the entrapment is done. The size of the matrix pore is such that the enzyme is retained while the substrate and the product molecule pass through. So enzyme only you can say it is get entrapped into that particular in particular that system. The deactivation may occur due to the changes in the pH or the temperature or addition of the solvent. Now, if you want to take out that enzyme from that matrix, so how you will do? You can change the pH or you can change the temperature or you can add some solvent to get that enzyme back from that entered polymer. The polymers which are used for the entrapment are the polyacrylamide gel or collagen, gelatin, starch, cellulose, silicone or rubber. These are few examples which are used for the enzyme entrapment. The enzyme inclusion gels also used, enzyme inclusion fibers and the enzyme inclusion microcapsules are used for the entrapment of the enzyme. So this is how you can see, this is the gel, this is the matrix form and the enzymes are get entrapped into this matrix form. So this is considered as an entrapment. It is the one of the example of the enzyme immobilization. Next, we will see the enzyme inclusion gel. How enzyme inclusion gel works. The enzymes are held on a solid support, that is matrix, by the weak forces such as the hydrogen bonding. So due to the hydrogen bonding, enzymes are held on the solid matrix or solid support. In the enzyme inclusion in the fiber, they are trapped within a structure of a solid polymer. They are not bonded with any bond, but they are entrapped or they are trapped within a solid structure. And the last one is the enzyme inclusion in the my Microencapsulation is another more expensive method, involve the enzymes which are both covalently bonded to and cross-linked within a matrix. So they are covalently bonded to each other and as well as they are cross-linking within a matrix. In that matrix they are cross-linked. Now, the next method for the enzyme immobilization is microencapsulation, the process of spherical particle formation wherein liquid or the suspension is enclosed in a semi-permeable membrane. So here what you can do a spherical or you can produce a spherical particle formation wherein the liquid or the suspension is enclosed, a particle in which inside that particle the suspension is enclosed. The membrane may be polymeric, lipoidal, lipoprotein based or the non-ionic in the nature. Again, depending upon the use of your enzyme or for purpose, you can use this material. Now there are three ways for the developing micro capsules. The first one is building a spherical membrane reactors. Second one, formation of the emulsion, and the third one is the stabilization of the emulsion to form the microcapsules. Now you can see the example. The pancreatic cell grown in the culture can be immobilized by this method. Suppose pancreatic cell, you want to produce the enzyme of the pancreatic cell grown in the culture, so you can immobilize these cells with the help of microencapsulation technique. So this is how the semi-permeable membrane is there. So this is the polymeric or the lipoidal or the lipoprotein membrane, and the enzymes are entrapped in this in the spherical particle. The next one is the next method for the immobilization is the covalent binding. The first one is the canogen bromide activation. The inert support material containing glycol groups are activated by the CNBR, which binds to the enzyme. CNBR is nothing but the canogen bromide activation. So the group get activated with this compound. Then diazotization. Support the support or the porous glass are treated with the NaNO2 and the hydrochloric acid HCl. They bind to the tyrosyl or the histidine functional group, and they are binded covalently. The next is peptide bond formation. Formation of peptide bond between the carboxyl group of the support and the amino group of the enzyme. So here it is explained by which chemicals how you are going to form a covalent bond with the inert support. Then the activation by or polyfunctional reagent, the glyceraldehyde can be used to create the bonds between the amino group of the enzyme and the amino group of the support. Now, in this particular example, the support also contain amino group and the enzyme also contain amino group. So, this glyceraldehyde can be used to create the bonds between them. See here the covalent bond between the enzymes and the support. So, these are the enzymes and these are the support. So, these covalent bonds are formed with these four different types of the chemicals or four different by these four different methods. So here is another example. Here is the support, the first example of CNBR. Then it is reactivated and the enzyme is again binded or enzyme the immobilized enzyme you can see here. So same here and here. The last method of the immobilization is the cross-linking. So the absence of the solid support is characteristic feature of the immobilization of the enzyme by this method. So up till now what we have used the inert support for the immobilization of the enzyme. Enzyme get trapped, enzyme get covalently bonded with that inert support, or directly they attach to that inert support, but in this, the support is absent. The enzyme molecules are immobilized by the creating cross links by involvement of the polyfunctional group. The polyfunctional groups are involved in the particular reaction, and the enzyme molecules are immobilized by creating the cross link with the involvement. Now, the reagents reacts with the enzyme molecules and from bridges which from the backbone to hold the enzyme, and this is why we don't require any support material in the cross-linking type of the method. Example is glyceraldehyde, toluene diisocyanate. The cross-links formed between the glyceraldehyde are irreversible and can withstand high pH and the temperature. So this is one advantages. So you can use this cross-linking type of the immobilization technique over a wide range of the pH and the temperature. Then the technique is easy and the cost effective. Here we don't require any support material, so it is the cost effective, and you only use this the chemicals glyceraldehyde or the toluene, so it is easier one. So this is how the enzymes are linked together, or the enzymes are cross linked together to form a copolymerization. It is the one of the type of again immobilization technology. Now we will see the application of this immobilization technology. The first one is the industrial application. The immobilized enzyme used, the first one is the amino acylase. The amino acid is used in the production of the L amino acid from the D or L acetyl amino acid. The next one is the glucose isomerase in the production of high fructose syrup from the glucose. So these are the some examples of the enzymes which are used in the various part of the industry. The example, production of the high fructose syrup. The high fructose syrup contains the equivalent amount of the glucose and fructose. This high fructose syrup is similar to sucrose from the nutritional point of view. The substitution in the preparation of the soft drink proceed food as banking as backing. An enzyme used in the evaluation is the glucose isomerase. Starch or potato, wheat or corn we can create, and we can use the alpha amylase and the glucoamylase, which can produce the glucose. And this glucose, after mixing with this glucose isomerase and enzyme, it will produce the high fructose syrup. This glucose isomerase is the intercellular enzyme produced by the Arthrobacter bacillus and the streptomyces. These are the sources of this glucoisomerase. Now the second thing is analytical application. The first one is the industrial application and the second one is the analytical application. So the first is biochemical analysis. They are used in the development of the precise and specific analytical technique for the estimation of several biochemical compounds. The principle of analytical assay is the action of immobilized enzyme on the substrate. So you can see here the immobilized enzyme used is the glucose oxidase, ureases or cholesterol oxidase, and the substrate acid is glucose, urea or cholesterol. The second one in affinity chromatography and purification. So this can be used in the chromatography also and the purification also. It can be used in the therapeutic application. The first application is the industrial application, second application is the analytical application, now third application is the therapeutic application. Now you can see here immobilization of the streptokinase and urokinase can be used for the treatment of thrombosis. The treatment of inborn errors, phenylalanine hydroxylase to treat the phenylketonuria. The urease modulate system is used as you can see here, and this is the reaction. The glucose oxidase glucose modulate system, in this also to decrease the pH, the immobilized glucose oxidase is used and insulin in the pH sensitive polymer. So this is how we have studied the enzyme technology. We have studied the introduction part. We have studied how the enzymes are immobilized, what are the advantages, what are the disadvantages, what are the five methods of the enzyme immobilization technology, what are the advantages, how exactly they done, and the last one is the application part, how enzyme technology is used in the industry application, for the analytical application, for the therapeutic purpose. So I hope you have understand the enzyme technology chapter very well. If you have any query, you can ask personally or you can comment down below. Thank you.